Okay, in this video we're going to use some of the rules of exponents that we've been learning about to solve some equations with exponents. And in particular, the equations that we're going to solve, the unknown value, the x that we're solving for, is going to be in the exponent. So there's a rule, we're going to call it rule number 6, that says if we have an equation that looks like this, if we have a to the m power equals a to the n, that is, some number raised to a power equals that same number raised to a different power, then we can set the exponents equal to each other. So we can just write this, m equals n. And if we take a look at this example right here, 9 to the power of x minus 3 equals 9 to the power of 7. Well, this equation right here, it matches this, what's in this red box right here. 9 to the power of x minus 3 equals 9 to the 7. My a value, my base, is 9 in this case. And I can see that I've got 9 raised to a power equals 9 raised to another power. Well, anytime I have this situation that matches this right here, then I can just set my exponents equal to each other. So x minus 3, that's the exponent on this side. 7, that's the exponent on this side. Well, if I just set those two exponents equal to each other, now I've got a fairly simple algebraic equation to solve. I just add 3 to both sides, and that gives me x equals 10. And I've just solved this equation. Now, very often you have an equation in which you don't already have this situation right here, and you might have to do something to your equation in order to get it to look like this. For example, this example number 1 that you see in your notes, 5 to the power of x times 5 to the power of 2 equals 5 to the power of 7. That's almost like this previous example, except I don't have a single number raised to a power. I've got 5 to the x times 5 to the second power. Well, I can use one of my rules of exponents, the one that allows me to multiply two exponential expressions. I know that if I have 5 to the x times 5 to the power of 2, I can write that as, I write down my base and I add my exponents. So I've just combined these two expressions into a single expression that has a base of 5 and an exponent of x plus 2. Well, now I have exactly this same situation that I have up here in rule number 6. Which means I've got a number raised to a power equals that same number raised to a power. Well, then I can set my powers equal to each other. So in this case, x plus 2 is the power on this side. 7 is the power on this side. And again, I've got a fairly simple algebraic equation that I can solve. X plus 2 equals 7. I just subtract 2 from both sides. And I've got x equals 5. Now, when you're solving these types of equations, you notice how I drew a box around this particular part of the equation. I drew a box around the part of the equation that matches this box right here in my rule 6. And I'm going to ask you to do that for each one of these types of equations that you solve. Always draw the box around this part of your equation when you get to that step in the equation. Now, you've got several more examples there in your notes. I want you to try those on your own, and we'll take a look at these answers in class.